Hi everyone, I'm Théo from OKP4, the Open Knowledge Protocol. And today I'm going to talk about why the future of blockchain is off-chain coordination, especially through the orchestration of off-chain things like data and algorithm. So let's go in. We all know about oracles, right? Oracles, they gave the ability for smart contracts to access off-chain things, off-chain data, like price feeds, like events in the real world. And this is awesome. I mean, it enabled a lot of new things, like DeFi, like insurance or sports betting. And this is good. But the whole digital world, it won't run fully on-chain. And a lot of use cases run on private databases, on algorithms that are in closed environments. And I mean, that's for a reason, right? It has its use cases. But maybe blockchain has something to do with that as well. What if we could use smart contracts as a source of truth, as defining some rules to initiate actions on off-chain data, like giving access to something or defining any kind of rules. And not only data, but anything off-chain. Data sets, algorithm, storage, computation, anything that is off-chain could be orchestrated through the smart contracts, through the source of truth that is a blockchain. OK, what would we do this? Why would we do such thing? First, we have to learn that knowledge is derived from two things, data sets and algorithm. For example, maybe a few days ago, you heard Vitalik may come today to Nebular Summit. That's a data. And your brain, the algorithms, process that data. Oh, I love Vitalik. He's awesome. Maybe I should come to Nebular Summit. Coming to Nebular Summit is the action, is the knowledge, is something that creates the value, not the data itself. And in our digital world, data sets and algorithms, they are everywhere. It's just that they are in siloed system, they are not accessible, and they can't interact with each other. So the real problem here is that they're not shared. And because they're not shared, the knowledge can't be created, and the value can't be created. So that's a huge issue for society at large, basically, because a lot of problems require knowledge that is not created. So why is that? Why are data and algorithm not shared? Mostly for three reasons. The first one is a lack of trust. I have data, maybe personal data. I don't trust you enough to give you my data. Maybe you will do something I don't want with it. So this is something that prevents me from sharing that data. Also, there is a lack of incentives. OK, why not sharing my data? But why? What value? Financial? What kind of applications will I access if I share my data? It needs to be clear. And the third reason is technical. It's fragmentation. There is a lot of silos, databases that are not, that can't interact with each other. And this fragmentation is another friction that prevents data and algorithm sharing. So let me give you an example to explain these concepts. This example is carbon credits. So maybe you know about this. Carbon credits is something that is one of the main tools to incentivize companies to be aware of their carbon emission and to prevent them. And to calculate carbon credits, basically you need three things. The first thing is data collection. You need a lot of data to do that. You then need to calculate the carbon credits with an algorithm. And then you need someone, some organization, to issue the carbon to say, OK, this is legit and can be sold on the market. So this is an example that was enabled by OKP4. So some companies are building on it. And regarding the data collection, there is two entities. An accounting association that has accounting data, about 20,000 farms. A farming cooperative who has more of technical data about the practices of the farmers, of the same farmers. Then you have a research institute that has an algorithm to do the calculation. And then another company that issues the carbon credit and has a marketplace to sell them. And these four organizations, there is a problem. Mostly they don't trust each other, especially if there is an accounting association that has some sensitive accounting data. Of course, you don't want it to be accessed by anyone else and by the other participants. Same for the farming cooperative. Also, they don't know how to share the value. They all have data, but how do you measure the contribution of everyone? And how do you share the value of the carbon credits? That's also an issue. And of course, they all have their own infrastructure, their own servers, and there is no common infrastructure to enable these datasets and algorithms to interact freely, easily together. So these three problems, basically, you have data and algorithms that exist, but they are not shared, so the carbon credit can't be calculated. So maybe you know where I'm going. Trust, incentives, composability. It's all about blockchain, right? And so this is what blockchain are good at. They are good at creating the right trust environment or removing the need for trust to enforce some rules. They are good at creating incentives to even design some tokens or some mechanics for sharing the value and providing the right incentives for everyone. And they're great at composability to enable to be like a protocol, to enable anything to interact with other resources. So that's what we've built at OKP4. Basically, it's an infrastructure to share any kind of off-chain resource, off-chain data, off-chain algorithm, anything, to define some rules on-chain, any kind of rules, like access rights, like business model, anything. This is defined on-chain. And then once you have the resources and you have the rules, you can initiate workflows between the different data sets and algorithms based on the rules that are defined on-chain. And this enables new things to happen. Let's go into more details about how it works. So this is still the carbon credit use case. So you have the carbon credit issuer who creates a zone. So a zone is a set of rules. So he's going to define what are the rules of the zone. So this zone is for carbon credit calculation. Maybe the issuer wants to keep the control of the ability to change the rules. He will define what kind of data, what kind of structure, what kind of format needs to be shared within that zone. And these are the rules that are defined on-chain. Then the different participants, the providers of data and algorithm, will share their data. So basically, they don't have to put their data anywhere else. They just describe it on-chain. They said, oh, this is a metadata, this is a description of what I share, and this is the way you can access it. This is the rules that apply to access this data. And so now you have the different data sets, the different algorithm, and the rules to enable them to interact with each other. So you have the carbon credit issuer who will initiate a workflow. So basically, he will submit a transaction on-chain with saying, oh, I want these different data sets to interact with this algorithm. And if the workflow it complies with the rules, then the validators will say, oh, OK, it's compliant with the rules. And there is mostly the off-chain world, the workflow engine, and the different data sets and algorithms that are going to interact with each other because it was allowed by the blockchain. And this new data set, that is the carbon credit, basically is the knowledge, is the source of value. And this is the only thing that is going to be used by the marketplace. So in this situation, the data sets, the algorithms, I mean, they are not exchanged with anyone. And still, they created some value through the carbon credit calculation. So now, all the different resources that were shared, they can interact with each other. The value is created and shared according to the business model that they defined. And the trust requirements are minimized. They didn't need any trusted third party in the middle to make that happen. And still, they can keep the ownership of their data and the sovereignty over it. So the first consequence of that is that, as we've seen, we had existing data from the different organizations, existing algorithms, existing application. The value was created just by the act of sharing, just by the act of opening the silos, opening the gates between these things that already existed. And this is where the value was created. And that's already awesome. But there is a second order consequence of that. We have this zone that is designed for carbon credit, but maybe someone else is interested by the data that were shared through the protocol for this use case. So maybe this person is doing some research about cancer, for example, and they need some data about the farming practices, data that is already available there. So they will create another zone that has compatible rules with the zone A and share their data. So maybe this is the data about cancer cases in specific region, and in the zone A you have the data about the practices of the farmers, and especially, for example, the pesticide use. And by creating a zone that is compatible, they can enable this data to interact with each other, and they can create a new form of knowledge with the same data. The providers don't have anything to do, just the rules still apply, and they will have some value from the data they share. And of course, it creates new knowledge. It creates a new value chain for the different data sets and algorithm. So in this design, the data is not sold. It's not a marketplace. You didn't have to give your data to someone and put a price on it. Data kind of become a yielding asset. It's something that creates value, recurring value, every time it's used. And because you don't exchange it, you don't lose the ownership of it. And this is where the value lies. So let's go back to our reverse Oracle story. So remember, we have the chain, we have the smart contracts that can orchestrate anything that is off-chain. And it's literally anything. I talked a lot about data and algorithms, but it can be software, it can be storage resources, computation resources, identity mechanisms. Anything that is off-chain can be orchestrated through these smart contracts. And it's in any way you want, in any rules you want, in any design you can think of. We're building the infrastructure to make that happen and to give the freedom for builders to create their own rules. So all of this is what we call the dataverse. So the dataverse is this ever-expanding universe of resources, data sets, algorithms that are shared and that are made available through the protocol and that can interact with each other for many, many purposes and use cases. So let's go into another example, AI. So you know AI-powered machines, they are created every day by the thousands. They are getting better every day. They are probably going to take your job. I don't know if that's good. They are controlled by a handful of corporations. And as AI become more powerful, more valuable, of course, this corporation will become even more powerful. And that may be bad because it may influence, in a bad way, how society works. And the value will get even more concentrated. So what if AI could be collaboratively trained, collaboratively owned, and collaboratively governed? That's something that may prevent these big companies to take all the power and have a huge influence on the fabric of our society. So this is something also that you can do with OKP4. So tomorrow we're going to reveal the different no-code interfaces to make that happen. So anyone can build this kind of zone and this kind of mechanism by using no-code tools that we've built. But basically, to make it happen, you have to create a zone. So you define what kind of requirements, what kind of data you want to be shared through that zone. You need to define the mechanism to quantify the contributions. You need to define what are the authorized parties. Like if you want to use decentralized storage or computation, you can make it as a rule. You need to define the the governance mechanism to change the rules. So in this fashion, you want a custom token. You want it to be decentralized as a governance token. And you need to define the business models. And these are the kind of rules that you can define on chain. And then once the zone is created, anyone can share their resources according to the rules. So the data sets to train the algorithm or even some curation mechanism, the computation power, everything can be shared. And so now, once you have the resources and the rules, you can initiate the workflows based on them and train this really open AI and not the open AI that is kind of owned by Microsoft. So that may be cool. So OK, but how does it work? I won't dive too deep into the details. You can read the docs. You can talk to our technical guys and awesome team. But basically, it's around 3 pillars. The first one is governance. So we created a Prolog interpreter. So it's a module that enables to define and interpret any kind of rules on chain. And that's for the governance on the low side. Then you have the ontology. So the ontology is a semantic description of everything that is shared through the protocol. So every data, every algorithm, and the relationship between them. And then the third pillar is the orchestration. So it's now that we have the resources, the data, the algorithm, and now that we have the rules, how do we enforce the law that is designed on chain, and how do we make things happen off chain? So this is the orchestration side. And that's really mind-blowing. I mean, it may seem simple, but it enables a lot of new use cases for blockchain, for crypto at large, and in the real world, not only in DeFi and NFTs. It's really something that may create a lot of new things, pretty exciting. And there's more. As you know, so we're building a chain, an app chain, on Cosmos using Cosmosm. And you can see OKP4 kind of as a bridge between the Web2 world, using blockchain to orchestrate actions in the Web2 world. But we're part of the IBC ecosystem, and we will benefit a lot, and other protocols will benefit a lot from that by creating, for example, if you want to, I don't know, store your data in a self-sovereign way, you can use Jackal, or if you want to use decentralized computation, you can use Akash, or if you want to use DID mechanism, you can use Checked. I mean, the IBC ecosystem is very, very rich with other protocols that are very specialized, and we can create a lot of new use cases for Cosmos through IBC and through the interoperability between the different protocols. And with the goal is really to bring and to onboard real-world use cases to Cosmos. So already we have mostly B2B use cases with, for example, in agriculture, in logistics, in transportation, in health. I mean, that's a use case we've started with with OKP4 as a company. But now that we have the testnet ready with all the technical design and the mainnet coming, that's new use cases that are going to come. And that's new use cases that are going to be built by builders for the Interchain and for the Web3 native. So what's next? Right now, we have the Builders program, a Builders program that is designed to onboard developers to learn about the protocol because it's pretty new. It's pretty. It can be pretty. Yeah, it's different. So we need people to be onboarded. So right now, if you are a developer and you want to learn about how it works and be kind of the first ones to contribute and to benefit from that, you can earn a lot of tokens through that Builders program. Then, of course, we have new use cases that are coming. Tomorrow, as I mentioned briefly with Emmanuel, the founder of OKP4, we're going to reveal for the first time the interfaces of the protocol, the no-code interfaces to create your zone, to define the rules, to share the data, the algorithm, to initiate the workflows. All of this can be done in a no-code way, and we're going to show how it works. And I think you don't want to miss that. And of course, we'll do a mainnet announcement by Cosmoverse in Istanbul, because it's coming soon. So to conclude, I want to finish with this quote from Punk 6529, is that the ultimate use of token is to coordinate real-world behavior at scale. And I think this is a very powerful quote. I think what we're building is really, it may enable a lot of new real-world coordination mechanisms. And I mean, if you agree with me, if you feel a bit excited about this, I mean, feel free to discuss with the team. We have a booth over there. The team is everywhere. We're awesome guys, so happy to discuss with you and let you learn more about OKP4. So this is me. Thank you.